Today we're covering the addition method for solving systems of equations, linear equations. We have a system here with two equations and two unknowns x and y. We have another system here, and we have a few more that I'd like to do. In the addition method, you try to eliminate one of the unknowns, x or y. So you look for a number in front of x or y in one equation, and then in the other equation you look for the opposite number. For example, here we have 4 and minus 3, they don't cancel, but plus 1 and minus 1 will cancel. And if they do, we're going to say add these two equations. When you add minus 3x plus 4x, that'll give you 1x. Plus y minus y will cancel, and then 4 minus 2 is 2, so x equals 2. Next, put x equals 2 in one of the equations, this equation or this one, so that if we put it in the first equation, minus 3x plus y equals minus 2, x equals 2, put x equals 2 here, so minus 3 times 2 plus y equals minus 2. Minus 3 times 2 is minus 6 plus y equals minus 2. To solve for y, add 6 to both sides, plus 6, and that'll give you y equals 4. So x equals 2, y equals 4. We can also write it like this as a pair, 2, 4, and that's the solution, and the problem is done. Let's solve another problem. This one, 2x plus y equals 7, 3x minus y equals 3. So in this system we have a minus y here and a plus y. Minus y plus y will cancel if we were to add these equations. So if we add them, we get 3x plus 2x, which is 5x. 3 plus 7 is 10. 5x equals 10 is a linear equation in one unknown, x. Divide both sides by 5, and that'll give you x equals 2. Put x equals 2 in one of these equations. For example, in the second equation, 2x plus y equals 7, x equals 2, so 2 times 2 plus y equals 7. 4 plus y equals 7. Subtract 4 from both sides, and that gives you y equals 3. So the solution is 2, 3. You can check this system. You can check if 2, 3 is a solution by plugging 2 for x in both of these equations and 3 for y in both of these, and see if both of these equations are true. Like if the first equation gives you 3 and the second equation gives you 7. We're going to do another system. Let's do this one. In this system, in the first equation we have minus 2x. In the second equation we have plus 2x. If we were to add them, I'm going to put add under the x's. Minus 2x plus 2x will cancel. 5y plus 3y will give you 8y. 15 minus 7 is 8. Divide both sides by 8, and that'll give you y equals 1. Let us put y equals 1 in the second equation. Again, you can put it in the second equation or in the first equation. 2x plus 3y equals minus 7. Y equals 1, so 2x plus 3 times 1 equals minus 7. Subtract 3 from both sides, and that'll give you 2x equals negative 10. Divide by 2, x equals minus 5. This time the solution is, we got y first, but y goes in the second position of the pair. X is minus 5, that goes in the first position. For my students, you can give the answer as x equals minus 5, y equals 1. That's acceptable. Or you can give it as a pair, minus 5, 1. And you can check this by substituting minus 5 in the original system for x and 1 for y. Are the equations always like this? I mean, you'd have a minus and a plus in both equations and they'll cancel? The answer is no. You could have systems like these, like the next one, 204. In 204, none of these numbers cancel. The 2 doesn't cancel the minus 10, and the 3 doesn't cancel the 2. So what do we do in situations like this? This is what we do. We figure out what number to multiply one of the equations by, or both equations, so that one of the unknowns will cancel. I'm going to multiply the first equation by 5. If I do, 2 times 5 is 10, and 10 will cancel the minus 10. So make sure you multiply every term in the first equation by 5. 2 times 5 is 10, so that's 10x. 3 times 5 is 15y equals 15. Now look at these two equations. We have a minus 10x and 10x. When we add the equations, the x's will cancel, the y's will add up. 2y plus 15y is 17y. Minus 32 plus 15 is minus 17. So now we have one equation in one unknown. Divide both sides by 17, and that'll give you y equals minus 1. Substitute y equals minus 1. Now you have three choices. You can substitute in the third equation, second, or first. Let's go to the first this time. 2x plus 3y equals 3. But y is minus 1. So 2x plus 3 times minus 1 equals 3. 2x minus 3 equals 3. Add 3 to both sides. 2x equals 6. Now we can solve for x. Divide by 2, and that'll give you x equals 3. So x equals 3, y equals minus 1. That's the solution. And again, my students can leave the answer like this, or you can write it as 3 minus 1. What if multiplying once does not result in the elimination of x or y? We may have to multiply twice, and this is the most work we would do in any of these systems. If you look at this system, you got 3 here, you got 4, you got 2, you got 5. We need to first pick which letter to eliminate. If we want to eliminate, let's say, the y, we have 2 here and we have 5. So we shoot for 10. 10 is a multiple of 2 and a multiple of 5. If we wanted to eliminate x, we shoot for 12. 12 is a multiple of 3 and 4. Could we also shoot for 24? And the answer is yes, because 24 is a multiple of 3 and a multiple of 4. So you don't need the least common multiple. Any common multiple will do. So I'm just picking y at random. I'm going to shoot to eliminate y. So I need to multiply the first equation here times 5 and the second equation times. Okay. If we multiply the second equation by 2, we're going to end up with 5 times 2, which is 10. 2 times 5 is 10. They don't cancel. So one of them needs to be a minus. So we need to pick, let's multiply the second equation by a minus 2. First equation times 5, that gives us 15x plus 10y equals 85. Second equation times minus 2 minus 8x minus 10y equals 32 times minus 2 is minus 64. Okay, when we add now, the y's are going to cancel. So add, and that'll give you 15x minus 8x is 7x equals 21. Divide both sides by 3. I'm sorry, by 7. I was thinking of the answer ahead. So x equals 3. Divide by 7 because it's the 7 that's in front. X equals 3. Put 3 back in any of these 4 equations and that'll give you y. Let's pick the first equation. 3 times 3 plus 2 times y equals 17. So that's 9 plus 2y equals 17. Subtract 9 from both sides. So that'll give you 2y equals 8. Divide by 2 and that'll give you y equals 4. So the solution is x equals 3, y equals 4. And again, if you plug in x equals 3, y equals 4 in the original equations, they will both be satisfied. And this completes the addition method.